point to graph. But I also know at 0, y is -3, right about there. But I know I have a turning point down here somewhere, right? Didn't we have a turning point over here somewhere? I can actually find that. I'll show you real quick how to find that turning point. It's second calc, and I would like to know the minimum. So I'm going to choose number 3. And there could be more than one minimum, so I'm going to scroll to the left. It's very much like finding a 0. I want it to find a left boundary and a right boundary to tell me where is the minimum. Now I'm going to go over to the right side, and I want, yes, in case it's not a whole number. Okay, I have a minimum at like -1.25, -6.125, so roughly -1, -6, roughly -1, -6. Okay, that's a turning point. And then I have another 0 at, oops, .5. I forgot to draw it on here, didn't I? There it is, 0.5. Okay, so now I just need to kind of connect these and make them look like a good loop. There's certainly other points I could get. You know what, though? Drawing that looks like it's going backwards. That is not what I want. So what are the crucial points I have here? I have a 0 at -3. I have a turning point roughly -1, -6. I have a y-intercept at -3, and I have a point between 0 and 1 at 0.5. If I get those all on my graph and on my graph here, then I'm doing okay. And this is the function y equals 2x squared plus 5x minus 3. And I have zeros at -3, 0. Put it in here, -3, 0. And I have a 0 at 0.5, 0. Okay, now what does that mean? That means if I put a -3 into this function, the answer is 0. And if I put a 0.5 into this function and evaluate it, I get a 0. So there's two solutions to this function. There are two ways in which the function will yield a 0 when y equals 0. Remember, y equals 0, I'm on this x-axis. I hope I've showed you